The adolescents feel in a worse mood even after they'd been included in the catching game, because they were in a really bad mood after being excluded, but they all went down a little bit anyway.
Well, that was not a significant decrease, so it was a very small but non-significant decrease in mood, so don't pay any attention to that.
Just here in the second row. Yeah.
Is there any evidence that our changing environment, particularly in the way we communicate using these things, is changing the way that teenagers' brains are developing and operating?
Yeah, so the question about screen time and technology and social media and how that affects the teenage brain is obviously a really, really important question. Everyone wants to know about whether there is any effect and whether it's a bad effect. And the answer is actually we really just don't have the scientific studies yet on the effect of social media and screen time on the developing brain. It's starting, but we just don't have any data yet. So there's a lot of kind of worry about it, but whether that worry is justified or not, I can't say. No one can really say now. One thing I would say about screen time and social media is that, I mean, it's very, mesmerizing and motivating. Young people do seem to want to spend a long time, and we all do. We find it hard to put our mobile phones down. But the one thing that I've noticed is that a lot of young people I work with or know want to be checking their messages and their Instagram likes or whatever it might be throughout the night. And that is really never going to be a good thing, because sleep is so critical to well-being and mental health and learning and mood. And so having disrupted sleep because your mobile phone is going off through the night, wouldn't be good for any of us, but it's something that young people will often do, say they do. So that's the one thing I'm pretty confident about saying, but in terms of the effect on brain development, we just don't know yet, but we will. There's a very, very big study of 10,000 9 to 10-year-olds being tracked over 10 years in America called the ABCD project, the Adolescent Brain and Cognitive Development Project. And one of their questions, they've got lots of questions and they're going to take lots of measurements, and one is screen time and social media. So that will tell us a lot.
I'll just add to that, for a fairly recent and brief summary of the state of play on the research, if you Google my name, John Sutton, and seeing screen time differently, there was a brilliant event about 6 months ago that covered the fact that we don't know and why we don't know, because it seems quite frustrating, I think, to the public. Why don't scientists have answers to questions like this? But it's worth reading. I think in terms of the way it's changing how teenagers act, we were talking before, weren't we, about how teenagers have had this bad rap for millennia. But I just wonder whether that is starting to shift, whether we're on the cusp and we're seeing more teenagers involved in movements for social change, and in terms of how they vote, and in terms of standing up for gun control and things like that, and whether that's in quite a large part being facilitated by their use of social media.
Yeah, I mean, the teenagers and adolescents are kind of another stereotype we have about them, which is based in some truth, is energy and passion for causes, and creativity, and also a bit of social influence going on there. And social media gives them a platform to enable that kind of passion, sometimes for the good.
Yeah. Okay, more questions?
Yeah, I wanted to find out, the developmental, is there a big difference between boys and girls, or is it really more an individual change?
It's a good question. I often get asked this question about gender differences in brain development. And of course, there are really big gender differences. I mean, if knowing teenage boys, teenage girls, it seems like they're very different. And you can see that in epidemiological studies, for example, of car accidents. I mentioned that earlier on. There's a huge gender difference there, as you might imagine. More young men have car accidents than young women. But we don't see that in the lab. We don't see that replicated in our studies of risk-taking and peer influence. And I think one of the reasons, which is what you were talking about, is that there's actually so much overlap between the genders that in order to see a difference, you'd have to have huge sample sizes. And even though our sample sizes in our experiments tend to run into the hundreds, that's nothing like epidemiological sample sizes, which can be hundreds of thousands. And the individual differences are, there are individual differences, and gender is just one of them. But the individual differences for a lot of things are kind of bigger than the gender differences. So the overlap, you just don't get the power to see statistically significant gender differences in our smallish studies. Yeah.
I'll shout, shall I? My question was whether there's any difference in direction of development depending on how much risk the teenager takes. So the question is whether there's difference in direction of development according to how much risk the teenager takes.
It's a great question. It's relevant to the previous question about individual differences, because everything I've told you is I've been really talking about average teenagers, but of course there's no such thing as an average teenager, just as there's no such thing as an average human. The individual differences will tell us much more than just averaging over and kind of ignoring the variance in the population, but that's just starting to happen. So, all of the things like the brain development patterns that I showed you, there are huge differences between individuals, and the question is, which is what your question gets at, the question is, what causes those individual differences in brain development? Is it something in your genetics or your environment? And by environment, there are so many different environmental factors that could play a role, like your culture or your socioeconomic group or your peer environment, your home environment, your education, your, even things like nutrition and whether you drink or smoke alcohol, or smoke cannabis. All of these things might contribute to individual differences in brain development and behavioral development, like risk-taking. And we don't know very much about that yet, because this is a very new area of science, and only recently have people started to ask those questions and interrogate those individual differences in brain and behavioral development. So we're starting to learn a bit now, but it's a question that's only just recently starting to be asked. And the second part of that question is what then happens as a result of that. So, if your brain develops differently, and each individual's brain will develop differently, what are the consequences for that in adulthood? So, for example, if you're a really, really risk-taking teenager, does that have some kind of outcome? Does that have some benefit in adulthood compared with if you're not a very risky teenager? Again, we don't know very much about that.
Hi. Question upstairs? Hi. Why does it seem that issues such as eating disorders and self-harming seem to happen during adolescence?
Yeah, so I started this talk by, or at least at the beginning of the talk, I told you about my interest in adolescence was triggered because I worked with patients with schizophrenia. And what I didn't say is that it's not just schizophrenia that starts in adolescence, but almost all mental health problems first appear in adolescence, whether it's depression or anxiety or self-harm or eating disorders. 75% of mental health problems start before the age of 24 years. And adolescence seems to be a period of particular vulnerability to mental health problems. Why is that? Again, the ABCD project, which I mentioned earlier in response to another question, that's exactly what it's going to look at, which is why it has such a huge sample size. It was Barack Obama's kind of last is where he put a lot of science funding just when he was leaving office into this ABCD project. And one of the major questions is, why do these different mental health problems start in adolescence? What predicts them? How can we predict who is going to become depressed, for example? And what does their brain developmental trajectory look like? But I would say that, why is adolescence such a period of vulnerability? Well, if you think about it, particularly early adolescence, it's a phase of so much change. It's a time of hormonal changes, huge increases in sex hormones. That will directly affect the brain and behavior and mood, but it also have an indirect effect because at puberty changes little children into people who look like adults. They look grown up, and that changes the way society treats them. I was talking to a primatologist recently who said that he works on chimpanzee behavior, and he said that when a chimpanzee goes through puberty, you can't really tell any difference initially between the way it behaves before and after puberty, but what you can see instantly is the way the rest of the colony treat that chimpanzee. And there's probably the same for humans. We treat young people very differently once they've gone through puberty because of the way they look and act compared to before. But then there's also social changes like school changes, going from little primary schools to big secondary schools. And now, of course, we know also the brain is undergoing a huge amount of reorganization and development at exactly that time. So all these different changes going on at the same time, I think, contribute to this period being a period of vulnerability to mental health problems.
Got one in the back row there.
Do you include any special needs cases in your studies? So dyspraxia, dyslexia, and is that a different brain as well?
I don't work on that question, but lots of my colleagues do in the US and Europe and elsewhere. And there is no kind of, again, the studies tend to be quite small, and the main findings are sort of small effects and haven't really been replicated. But the main conclusion for those conditions, and so developmental conditions like ADHD and dyspraxia and dyslexia and autism, and also mental health problems, is that it's very much about the development and not. So if you take a brain scan, a snapshot in time, you won't see much difference structurally between a group of children, say, who have a developmental condition like ADHD versus a group of children who don't have ADHD. Their brains look more or less the same. But if you scan them every year or two as they're getting older, you can see that often the trajectory of brain development is different. The way I describe it is it's like what route you might take home. So, going home this evening, you could take a train or a tube, or you could drive, or you could walk, and you end up at the same place. It could even take the same amount of time, but the route itself will look very different and feel very different. And that's the general finding from brain imaging studies of children and young people with different conditions, that it really matters how their brains develop.
I think we've probably got time for two more. Should we go for this gentleman in the second right?
Hi there. I was curious about your definition that you mentioned earlier with regards to your work, given that it seemed to start with something that was biological, with puberty, and then finish with something that was sociological with regards to the way people fit in and so on and so forth. And it seems to me that it'd be quite difficult to track that if you're trying to operationalize that in experiments over time. So are you going to sort of try and harmonize the two endpoints so that they're both social or both biological, or is there some other approach you're taking, or is that very much in flux and pretty much part of your research as things go?
It's a really good and difficult question. Mostly we, in my field of research, we define our age groups by chronological age. So we kind of, when it actually comes to it, when we publish our papers and analyze the data, we divide people up according to their chronological age. As I think I showed you in a couple of graphs, we might say, young adolescents are 11 to 14. And that's useful because it provides a kind of comparison with other groups' work where they've also divided up their groups by chronological age. But actually that misses a lot because, as you know, one 11-year-old can be very different from another 11-year-old in terms of their physical maturity. So 11 is an age at which puberty variation is pretty much maximal. You'll have some 11-year-olds who haven't got anywhere near puberty yet and they're little children, other 11-year-olds who are in late puberty and almost adults, and that variation is completely normal. So I think that really, this insistence on kind of trying to divide people up into chronological age, even though we all do it, is missing really meaningful information. In terms of the end of adolescence being defined socially, I think I like that because in some ways I don't, and this goes back to that first question you answered, I don't like to pinpoint an age that signifies the end of adolescence, because I don't think that's going to be true for everyone. However, there was a paper published in The Lancet a few months ago by George Patton and his colleagues suggesting that we should all globally reconsider adolescence as a period of life between 10 and 24. So maybe that is the way to go.
I'll let you pick one from the back where it's difficult to see. Yep.
Quick question on the elite performance. What is the main difference between the elite successful teenagers in domains of music or sports and the normal people?
Yes, there are some researchers who are really interested in that question about kind of expertise and why some young people become experts. And one area of interest is academic diligence, or just diligence. It's this very interesting phenomenon that has recently been discussed by Angela Duckworth and her colleagues that is interesting because it's a way of it describes the way some people, I mean, I'm talking about children and young people, but actually adults as well, are diligent. Even if they find a task really boring, they will diligently train and learn and have goals and reach goals. And the interesting thing about this is that it's not really related to IQ, so it's not related to intelligence, this phenomenon, this measure of diligence. It's another characteristic that I think is probably more related to conscientiousness and perseverance. So I think that's possibly it, that some people are naturally more conscientious and persevere more than others. But that's not to say that it's fixed. I mean, none of these things that I've been talking about today are fixed in any way. Everything really is trainable, including diligence.
If I could just try to kind of bring the final two questions together a bit there and bring it back to your book, because I'm sure you won't mind an extra plug for the book published by Penguin, available in the foyer. I think we spoke briefly about it before the event. Social capital, and in terms of the opportunities for social mobility, is huge, I think, in the life opportunities that young people have as adolescents. And if you read Professor Blakemore's book, in the first few chapters, it's really clear that in kind of late adolescence, early 20s, she availed herself of every opportunity there was to work with amazing people and visit incredible places. And I think it's part of scientists' responsibility to try to ensure that young people have those kind of opportunities and that they're provided within science wherever possible. And I think you've done plenty in terms of opportunities within your lab and mentorship of young people and reaching out to the creative arts and that sort of thing. And I think that's such a good example to set for our young people.
Yeah, I want to just follow up on that by saying that I was, in my kind of late teens, early 20s, pretty diligent. I was really into psychology and learning as much as I possibly could about psychology. But it came late to me. At school, I was not diligent until pretty much my sort of GCSEs or even lower six A-levels. Before that, I was, I wasn't the most popular student with my teachers. And because I wasn't very diligent, I was much more interested in hanging out with my friends and messing around. And I think in some ways that's important, because this idea that, I don't know, a one size fits all education, you have to do everything early, and if you don't, it's too late, is not right. And all this research that shows that the brain is undergoing so much development and is so plastic much later than we ever thought before, fits with the idea that it's never too late. It's never too late to learn and to become motivated and to train and become an expert.
There's one of these daft social media things I saw the other day that apparently your life is defined by what was number one in the charts when you were 14, on your 14th birthday. Now this is just a little weird thing that I do. If anyone gives me their birthday, I'm able to say what was number one in the UK charts on their 14th birthday. If
That's
I
a
just
useful
have
skill.
30 seconds and access to Google, I can do it. I can do it no problem. So with Professor Blakemore, it was Yaz and the plastic population, the only way is up.
Oh.
So maybe on her 14th birthday, that was a bit of a subconscious spark to start off on the
true.
trajectory
Regression to the mean.
that we've seen you on. So I think we'll continue to watch that rise throughout your career with great interest. All that remains is for me to thank the Royal Institution for having us. Thank all of you for coming. So thank you for the great soliloquy, which I think really added to the evening's proceedings. And thank you to Professor Sarah-Jayne Blakemore.